Hi everyone, in this video I want to tell you about the equation of a circle. And I want to start out by reminding you of the equation of a line because there are some important things that carry over to circles from the idea of lines. So you might remember that the equation of a line is y equals mx plus b. And so for example, we might study a line that looks like y equals minus 2x plus b, or plus, let's say, 6. And this number, minus 2, had some significance in terms of the graph. This number 6 also had some significance in terms of the graph. So what did these tell us? This told us that the slope, which we usually call m, is minus 2. And this told us that the y-intercept was 0, 6. So it intercepted the y-axis 6 units up. So these numbers gave us some geometrical information, even though they're just numbers in an equation. And you'll also notice that the equation still has an x and it still has a y. What this says is if I plug in a point on the graph for x and y, the equation will be true. So these are the two important things that we understand about the equation of lines at this point. That the m and the b have significance, and that the x and the y just represent that there are lots of points on this graph, and the coordinates for each of those satisfy this equation. So we leave it with the x's and y's. We don't have to have all numbers or anything like that. Now the equation from a circle, I'm going to give it to you now, and if you're curious about where it comes from, I have another video that explains how the equation for a circle comes from the distance formula. But the equation of a circle is this. We'll write it as x minus h squared plus y minus k squared equals r squared. So you'll notice we still have an x, just like in the equation for a line. We still have a y, just like in the equation of a line. But we have these new variables, h, k, and r, which when we write the actual equation for a circle, these are just holding the places of numbers. So for example, we might have a circle that looks like x minus 2 squared plus y minus 4 squared equals 16. In this example, our h equals 2 because x minus 2 is the same as x minus h, so 2 and h are the same. K equals 4, and r squared equals 16, so r equals 4. Technically r equals plus or minus 4, but we'll always take the positive, and you'll see why in just a moment. So our equation again, it keeps an x and it keeps a y, because if I plug a point on the circle into this equation, it will make it true in for x and y. If I plug a point that's not on the circle in, the equation will not be true. I won't get 16. So now, just like with the line, these numbers had significance. Let me tell you the significance of these numbers, h, k, and r. So here is the beauty of this equation. H, k is the center of the circle. So that says h is the x-coordinate of the center, and k is the y-coordinate of the center. So that's the first bit. The second bit is r is the radius of the circle. So now I have a lot of geometric information. My circle we'll have center h comma k. So if these are my axes, then this is h and this is k, and it will have radius r. So in the example here, what I learn is that the center is at 2, 4, and the radius is 4. That's why we take the positive, because the radius is a length. It can't have a negative length. So if I wanted to graph this one, I would plot the center 2, 4, and then if the radius has length of 4, then here's another point on my circle. Now I just trace it around. Let's be a little bit more precise in these next couple examples. But this is the key. H and K give you the center, and the constants on the right give you the radius. So here's an example. I have a picture of a circle. I want to find H, K, and R. So H comma K is the center, and this is the radius, R. So I can do that from my picture. I just want the coordinates of the center, and that will be this. So the center is here. So the x coordinate is 4. The y coordinate is, let's see, -1, -2, -2.5. And the radius is just the distance from the center to any point on the circle. So that's going to be 1, 2, 3, 4. So then if I go back to my equation, I could write the equation of this circle. It's going to be x minus 4 quantity squared, because h is 4, plus y minus -2.5, k is 2.5 squared, equals 4 squared, the radius squared. And I could simplify this one step further, because minus and negative is plus, so that will be x minus 4 squared plus y plus 2.5 squared equals 16. And that's the equation of this circle. So it's not too bad. You can read off the center from the graph, and then you suddenly have an equation for a circle. We can go the other way. We can draw a circle given the equation. So in this case, since the equation of this circle is x minus h squared plus y minus k squared equals r squared, well, my h is whatever is subtracted from x. So this is h. K is whatever is subtracted from y, but this is written as y plus 1 squared. So just like up here, I should think of that as y minus -1 squared, because now it looks like the equation. I have to have y minus k. So once I write it this way, I know that k is -1. And 4 equals r squared, which tells me that r equals 2. So now I know the center of my circle is 2, -1. So I'll plot that first. -1. And then the radius is 2, so I get some more points on my circle by just going 2 away from the center. And then I can connect them up. So that's the circle that you get from this equation. Let's do one more example that's like one of the harder problems on the web work. So I want to find h comma k and the radius. So I need to find the center and the radius if this is the equation of my circle. So what I want is for it to look like the equation of a circle. So x minus something squared plus y minus something squared equals something squared. So how do I do that? This doesn't look like that at all. The process is called completing the square. And under the review, I have a video where I show you why this process works. So I strongly recommend that you watch that video. So I'm going to rewrite the equation in sort of a funny way. I'm going to put some big spaces in between. The goal of completing the square is this. I want to add something to this expression so that I can factor these three terms as x minus something squared. So the trick is figuring out what I need to add here. We'll do that in just a moment. But you might be thinking that I'm totally crazy because I can't just add something to one side of the equation. Like, say if we were trying to solve this equation for x, or for y, and I just add 5. I can't do that. That completely changes the equation. If I added 5 to both sides, that's okay. So if I add something here, I also need to add it here. So let's do this, and then we'll deal with the y terms as well. So to figure out what I add here, the trick is I take this number, I divide it by 2, so that gives me -1, and then I square it. So that gives me 1. Now what I've done here, if I look at this trinomial, x squared minus 2x plus 1, is I created something that's going to factor like x minus 1 squared. You can check me if you don't believe me that that's how it factors. Since I added 1 here, I also have to add it here. Now this is starting to look like the equation of a circle. So I have x minus 1 squared. Let's deal with the y term. I have y squared minus 4y. I want to add something so that this will all factor as y minus something squared. Whatever I add here, I'll have to add here. To determine what I'm adding, to make it the perfect thing to add so that it factors like this as a square, I do the same process. I divide by 2, and that gives me -2, and then I square it, and that gives me 4. Add 4 to this side as well. So now I have the perfect trinomial because it factors as y minus 2 quantity squared. And on the right-hand side, I'll get 5. And I still have this plus in between that I need to bring down. So by doing this process of completing the square, I got this to look like the equation of a circle, where I have, this is my h, so h equals 1, k equals 2, r squared equals 5, and that tells me that r equals the square root of 5. So I hope that this example helps. If you want to understand where this process of completing the square comes from, please watch that video because I go through some really careful examples and do a good job of explaining the process. And this should be review from Algebra 2 anyway, this process. So good luck with the web work. Let me know if I can help with anything at all.